thermal fluid sciences experts. This is Pro Ready Engineer.
Hello, this is Bassam Abdelnabi from Pro Ready Engineer. I'm excited to share a new video series featuring industry cases. If you like what you see, please consider liking and subscribing. Take care and talk to you soon.
You know, when a critical industrial plant goes down, every single second of downtime costs a fortune. So the challenge isn't just to rebuild, it's to do it faster, smarter, and safer than ever before. In this explainer, we're going to break down an incredible case study, a high-stakes engineering challenge that was met with some truly world-class precision and expertise.
So, let's set the scene. It's Yanbu, Saudi Arabia. Back in 2018, a massive explosion rocks the National Petrochemical Company, or NatPet, polypropylene facility. The result? A complete, catastrophic plant shutdown. And just like that, the clock starts ticking.
And this image, well, it really gives you a sense of the sheer scale of the solution they needed. To get that plant back online, the engineers had to design and create a true giant from nothing, and under the most intense pressure you can imagine. What you're looking at right here is really the heart of that whole effort.
Okay, so let's really dig into this crisis and understand what was truly on the line. This was so much more than a simple repair job. This was a full-blown industrial rescue mission.
For a place like NatPet, a total shutdown is basically an existential threat. Every single day that plant stays quiet, millions of dollars in revenue just vanish. The pressure on everyone involved, the client, the engineers, the fabricators, was just immense right from day one.
So the root of the problem was this. 3 absolutely essential pressure vessels were completely destroyed. You couldn't fix them, they had to be replaced, and you can't just order these from a catalog, right? They had to be custom engineered and built on an emergency timeline. The race was officially on.
Now, of the 3 vessels they needed, one of them stood out as the single biggest challenge of the entire project. It was a true monster of engineering, the high-pressure blowdown vessel, known as D601. First, just try to wrap your head around the weight. The finished vessel was going to weigh 145 metric tons. That's about the same as 24 full-grown elephants. Just moving something that heavy, let alone building it, is a monumental task in itself. And then there's the scale. We're talking an inner diameter of almost 5 meters. That's about 16 feet across. A structure this wide presents huge challenges in just keeping its shape and integrity during the whole fabrication process. But here's the real kicker for the engineers, the shell thickness. It was up to 68 millimeters thick. That's over 2.5 inches of solid steel. Welding and forming plate that thick isn't just a skill, it's a science. This quote from the case study really puts it all into perspective. It wasn't just about building some big, heavy vessel. It was about doing it with a stopwatch running, where every single delay had a direct and massive financial impact. So how in the world do you even start to design something like this under that kind of pressure? Well, this is where meticulous planning and really deep engineering expertise come in long before you even think about cutting any steel. The design team had to solve a bunch of huge problems all at once. Like, how do you weld steel that's 68 millimeters thick without all that heat completely warping a 5-meter wide structure? And how do you make sure the steel keeps its strength after all that stress? These were the kinds of questions that needed perfect answers. The answer really started with the material itself. The team chose this very specific grade of steel, ASA 516 grade 70N, because it's a proven performer. It's known for being great to weld and for holding on to its crucial properties, even in super thick plates, which made it the absolute perfect choice for this high-stress job.
And absolutely everything had to be done by the book. In this case, that book is the ASME code. And let me tell you, this isn't just a guideline. It's the global gold standard for safety and quality. Following it means every calculation, every single weld, every inspection, it all has to be documented and proven to meet the highest standard possible. There was just no room for shortcuts.
All right, so now let's go from the drawing board to the fabrication floor and see how this amazing design was turned from blueprints into a 145-ton reality. This is where the team at Hidada Ltd in Jeddah really put the plan into action.
The whole process was just a masterclass in execution. First, they fast-tracked the materials, but made sure every single piece had strict ASME traceability. Then came the incredible job of rolling that 68mm steel plate into perfect cylinders.
They had to develop special multi-pass welding procedures. And finally, every single weld was inspected with advanced techniques, like X-ray, to make sure it was absolutely flawless.
So after all that pressure, all that complex engineering, and that incredible fabrication, what was the final result? Let's take a look at the outcome of this extraordinary effort.
The numbers really do speak for themselves here. The D601 vessel was delivered and it met every single one of those demanding specs. But most importantly, it, along with the other 2 vessels, made the successful reinstatement of the plant possible, letting NatPet get back to production. It's a textbook definition of mission accomplished.
And that's the real takeaway here. This project wasn't just a win for the client, it set a whole new benchmark for emergency response in the petrochemical industry. It proves that with the right team and the right expertise, even a catastrophic failure can be turned into a showcase of excellence.
It really leaves us with a powerful question, doesn't it? Excellence like this isn't forged by chance. It's forged by having the right partners and the right expertise ready to go before disaster strikes. It's about turning that insane pressure into an opportunity to deliver something truly extraordinary.
This case study is a perfect example of the kind of deep expertise you need for the world's most demanding engineering challenges. For those complex, high-stakes projects where there is absolutely no room for error, having a proven partner isn't just a good idea, it's the most critical decision you can make.